So, you've decided to take mechanical engineering as your course in college. Wonderful. Mechanical engineering is an amazing course with lots of practical applications, lots of jobs you can do after, and lots of science, math, and technology just waiting for you to open up. But it's not going to be that easy. You see, mechanical engineering is a very broad course. It's got lots of disciplines and subjects inside of it, such as signal processing, thermodynamics, chemistry, physics, chemistry 2, calculus 1. You've got statics and mechanics. These are all different courses which are also the backbones of other engineering courses. And due to the broadness of mechanical engineering, you're going to end up having to learn a lot of these different topics. And even then, by the time you're finished learning all of these, later on, you're probably going to have to learn even more specific topics due to your course or career afterwards. Now, a lot of these topics, what they have in common is that they require math. A lot of math. And I mean a buttload of mathematics. And while that may be intimidating for some, don't you worry. Because in this video, I'm going to be showing you what topics in math you're going to be expecting, at least in your first year of mechanical engineering. So, the first big bad guy that we all know and love and sometimes hate is calculus. Calculus isn't just one topic though, it's really three, sometimes four. And the first one you're going to be taking is calculus 1. Sometimes it's called single variable calculus, sometimes it's called basic calculus, but for us engineers here at CIT, that's probably engineering calculus 1. Now, this is just the very basics of calculus. You've got your limits, you've got your derivatives, and your first touch into integrals. And in comparison to all the other math you're going to be doing in the future, this is really just baby stuff. So make sure that by now, you get to practice and master all of these basics because they are going to be the very pillars of your mathematical future from here on out. But despite your discipline and your practice, you might still end up with situations such as these.
Alright, okay. Me, I love integrals. Show me the next one. Let's solve the next integral. Okay. 3x minus 1, x squared on the bottom. Pretty easy, right? Okay, let me think. This shouldn't be too hard, right? If I think about it, it doesn't look that hard. Um, hmm, hmm, um, okay. Uh, hmm, hmm. What is going? You know what, man? Screw it. I'm just gonna look at the solution, bro. Like I don't have the patience for this. Okay, here's the solution. Oh, okay. Oh, I see. Okay, pretty straightforward answer. I can see that happening. Well, what's PFF? Well, what is PFF? Per, what? Huh? Natural log. Whoa, how did he get that? What is P? Wolfram Alpha is giving me another answer. There's three answers, bro. That doesn't make any sense, bro. How do you figure that out, bro? Like, how? You'd have to be a genius to figure that out, bro. Like, huh? How?
So, if you're anything like that guy a while ago, you might have run into the same questions. And to be perfectly honest, you're actually kind of right. A lot of these techniques that we use to solve integrals, or even harder integrals, were invented by geniuses themselves, which is why we have a topic known as Calculus 2. Now, Calculus 2 is a topic that delves even deeper into integrals. So in this topic, we might encounter techniques that are used to solve even harder integrals such as integration by parts, trigonometric substitution, where we change normal trigonometric stuff normal algebraic stuff into trigonometric stuff. Or we might even have improper integrals, where we can finally solve functions and integrals regarding functions that approach infinity. And we might even have partial fraction decomposition, where we can finally solve integrals that have something to do with rational functions that have imaginary numbers. So, by now, you should have realized that there is a very, very vast ocean of engineering mathematics just waiting for you. So again, make sure you practice up because it's very hard to swim in an ocean if you don't even know how to swim or float in a pool. Now, it wouldn't be engineering if it was just mathematics, would it? We still have physics and chemistry. And just like in senior high, we had these subjects, right? But the difference is, you see, in senior high, we were given formulas for finding variables. But if you paid a little bit of more attention, you might have realized that the formulas for finding these variables are really just derivations of other bigger formulas. And if you paid even more attention, you might have realized that some variables are just derivatives or integrals of other variables. For example, the derivative of velocity is going to be acceleration, and the integral of acceleration is velocity. The integral of velocity is going to be displacement. And even for electric field, you can use integration techniques for charge density to find electric field. Now, see, in college, we're expected to use more sophisticated techniques like I mentioned a while ago, like integration and differentiation. So make sure, again, to practice your basic skills because you're going to need them for everything, even for chemistry and physics. So, that was it for a short summary of all the mathematics that you might encounter during your first year of engineering. Thanks for watching. I hope you have a good day and see you some other time.